welcome everybody for this 6-year workshop. I'm Luc Nicolas. I'm working together with Etel and together with my colleague Eugenia, who is just in front of me. We have prepared this workshop, which is based on the work we've been doing in IHE-Europe, the IHE-Europe project, since now a bit more than 2.5 years, where we are really trying to see how we can better connect primary and secondary use in a meaningful and concrete way. So what we have been doing is basically working on the current workflows. So the ones where people are investing a lot of time, money, resources to comply with requirements of European data sets and national data sets. Name them, infectious disease, cancer registry, AMR registry, and other registries. But we have been also working on a number of more prospective use cases where basically data set today needs to be collected much quicker and where we are in urgent need of consolidated knowledge, both at the level of the healthcare organization, but also at the regional and national level. So without further delays, because we have a very, very packed agenda for both sessions, I will share with my first presentation. What we have tried to do is to identify in Europe interesting initiatives where authorities, public health authorities, have been investing in strategies funded with public money in order to collect data at the source to feed registries. Okay, so we try to document at least what we used to call the only one strategy. So that the data which hopefully can be collected at the source can be reused with the minimum additional input from clinicians. So the first use case we documented was in Denmark. And Denmark is basically very interesting because they started very slow and very focused, I would say. They didn't try to have something which would cover the full spectrum of data set, but they focused on the key initial data set. And what is really interesting is they started from they tried to have immediately something back for the clinicians themselves. So basically, the first use case they had in mind is the benchmarking one. So they wanted to provide the clinician with some kind of benchmarking on their own practice at the individual level, but also at the level of practice, be it a GP, be it a specialist. And this, they focused on a number of aspects and clinical business case like diabetes, for examples. And what also is interesting is that they discussed of the added value with each specific specialty, meaning that they said, yes, those data are really important and they can create knowledge that we want to consolidate quickly. So that has been done in a very, in a co-creation way, I would say, but with a limited number of things. So we have been, they have been progressively extending the public health database and third-party application with adapted privacy modalities. So they started slow, but added year after year additional requirements. Although they have, as we can see here, only had quite limited semantic requirements, only for diagnostics, for example. The rest could be still collected in most of the time in free text. What is also finally interesting is that it's not only one public system, it's actually two systems. One has been for specialties by the public sector, and we had a second initiative driven by private sector for the GP EHR systems. And actually, they didn't immediately make it compulsory. They first developed completely the system. Can we try to stop that option? Yeah, and finally, also they came with legal obligation a bit later in 2024. So that has been quite successful because there was a very large buy-in and because the requirements were limited. Next. Yep, not working. Yeah, so very simple system, actually. Well, you have basically a pop-up which comes every time that you are in a data field which is concerned by a specific registry. And then there is an ETL process where the data are exported in a local databases, which is then being exchanged with the central databases. But actually, the data are specifically stored in a dedicated folder in the local systems. That's the specificity. The main consumers in the Danish card are basically the healthcare providers themselves. I've just mentioned it. The 28 national registers and also the 85 quality registers. So that's a huge population of registers, and also the region. And here you see the type of data which are concerned by all those lists. That's basically a diagnostic, the laboratory, the medication information, the patient ID, and some practice level identified information. So it's limited, but it has already provided interesting consolidation. So the big lessons learned is that they had a right calibration of the efforts and a balanced return on investment co-creation with a mix of drivers. They also have been developing other initiatives on the top of it, like we won't go into it today, but like Capri and Incept. And also this very important point about the industry is that the GP providers, EHR providers, have understood the benefit they could take from that and have decided to do it themselves and to unite. They created a joint venture to deal with this together, so to limit investment. So Denmark has, however, a problem, and the problem was the weight of legacies. They had a lot of national standards in place, and that remains still today a problem. So they really hope that with the EHDS, they will jump to a new stage and be in a position to align better. So in Belgium, we had this objective since a long time. So it dates back to 2013 already, where the principle of only once has been adopted in the first Belgian roadmap. And that led to an initiative where basically with public money, an application has been developed with the objective ultimately to capture as much data as the source and to feed the registers. It's not covering the whole universe. They started with some registers, but at least there has been a full inventory of all the registers operating in Belgium, which have been documented with the right metadata. And they started with some of those registers. So as you can see here, they started with infectious disease in particular, because that was one of the use cases where real monitoring in real time was seen as having a direct added value. So the application called HD4GP translates message standards into the standards required by the receiving system, including just the data format and the standards like HL7, DICOM, ANSI, and so on. So currently, Belgium is being a bit going further. There will be a presentation, I think, during the experience days on the new developments expected. So working a number of care sets, which could actually, for primary use, which would actually probably allow a better interface with secondary use. So that's a quick snapshot of the system, but it works basically on the same thing, is that it looks at what is available, then there is a validation, and then it's being sent, and then you complement with what is not available directly. So quickly, the lessons learned were that everybody recognized, and that was a strong request from the clinicians. They say, stop inventing new registries every day. Make sure you make use of what you have. try to work on quality and try to better connect with our systems. That was a call from the clinicians who were fed up of new initiatives coming from the public sectors and adding burden after burden. So they were happy about the system, not so much. We will hear, I think, some probably from Thierry just after me. As all systems, it creates problems at the beginning when it's implemented, as the requirements, expectations, and change management are not aligned immediately. So it takes time. And we need also, for this to work, that all the other investment in the tools which are necessary are there. So it's not enough. You need to have terminal server which are functioning, to have all the terminal resources correctly developed, translated, and mapped to the right specifications. So that's a lot of effort. And here again, we hope that the EHDS will provide a nice drive towards an easy. And finally, Finland is the last use case we documented, where everything looked fine. That was the country say, well, there's nothing to be done because they have already everything in place. There is per default a connection between primary and secondary use. We just, they are ready for it. Well, yes, they are indeed. We have a system here which through Kanta, which makes those information, and you see the type of information are extremely diverse, and there are a lot of data categories available, but they have also a system for all people who want to make use of those data there, but it's not for free, and it's still a bit difficult for people to really make use of the data. But I think the main problem that Finland has identified is that they could not work on data quality. So there is still a lot of garbage in, garbage out. So yes, data are available widely, but meaningful use is still missing. So they have a lot of work still to do, and to try to have the right strategy so that the data can be reused effectively. They also express concern that they don't make sufficiently use of those data. So I would just stop here with the summary of lessons learned across countries. Multiple drivers are needed. So you can't just have financial incentives. You need change management. You need to have something back for clinicians. You have all those elements to be there if you want to connect primary and secondary use. You need a major investment in usability. So the interface, in order to capture the data, needs to be multifold, not only one. People think with picture, with words, with whatever, but that has to be fit to purpose. Only once should be only once. If you have a system to capture data, but still you have 200 registers who still work independently, that's a nightmare for people, because instead of simplifying, you're multiplying the efforts. And of course, legacies are still an issue for a number of countries. And finally, both public and private initiatives have a role to play. And actually, sometimes when they work together, it can be extremely interesting. So that's what I wanted to do. I will drop this because we don't have time. And I will give it to Eugenia for the real stuff.
Thank you, Luc.
Yes, it would be very useful if you could provide us with a context of how care is provided in each country. With the respect to the responsibility of primary care for a patient versus secondary tertiary care for the patient, because this varies enormously from country to country. So in some countries, primary care does almost nothing. And people go just to get a prescription, but the primary care physician does very little in terms of diagnosis and treatment and management. It's all done in the hospital. Whereas in some countries, primary care does most of the management. And so therefore, the need to share information varies very differently because one, the amount of information in primary care where they do nothing is little versus thing. So understanding the context of the country is very important for us to understand where the country is in terms of its data sharing needs and what information it is moving around.
Yeah, thank you very much. Yes, indeed. That's why we have shown first the Denmark example, because it's exactly how they started. They started with primary care and basically the diabetes as use case. That has been their very first use case. But I think we need to move.
Yes, unfortunately, we have very limited time and we have very nice speakers that I would like to present. So my role is to facilitate actually the speakers today, which I would like to thank so much for coming here to share their expertise and their experience. They're all experts in interoperability. Each of them has their own perspectives. So we have perspectives from the clinical world, so from hospitals, from laboratories, but also from public health institutions and also from standard development organizations, or at least people working with them, with these standards. So I would like actually to welcome our first speaker, who is Dr. Thierry Klein, and who's the Chief Medical Information Officer at the CHR Hotsen Hospital here in Belgium, and who is also an expert, of course, in e-health.
So I will present my own experience in a hospital in Belgium. I'm working in CHR Hotsen, which is a little hospital, but I have another job. It's to help other hospitals to make projects around exchanging data and using data. So I will share my experience in my little hospital, but also as consultant in a big hospital in Liège. So the question is that, okay, what are the challenge to connect primary and secondary data? Is it possible? Is it an illusion? I will just share my little experience on it. I could not resist to share this slide because in Belgium, you know, this is a quite famous painting by René Magritte. This is not a pipe. Indeed, it's a representation of a pipe, and it's quite important to have in mind the concept and then also the representation, which is quite different from the reality of an object or the reality of the clinical work in a hospital. I don't want to comment this slide, but this is the frame of EHDS. Everyone, I think, knows that, but we have to cope with that because it's decided and it becomes reality for the hospitals in the next few months and years. In Belgium, in particular, Luc Nicolas has explained a little bit. The first priority in the hospital is to structure the data because we are working with electronic patient record. About 80% of the content of the electronic healthcare record is just text. It's quite important, it's interesting, but it's not reusable. And so the first step is to have, I would say, a terminal server, because if you want to code your information, you have to use SNOMED CT, and SNOMED CT is not just a table in a database. It doesn't work that way. You have to cope with a specific terminal server, because the maintenance of SNOMED CT is quite complex, and the electronic patient record software are not able to cope with SNOMED CT inside. You have to have a terminal server. This is the first step. It's not the case in every hospital in Belgium. In my hospital, I have installed with my team a little terminal server, which is functional but not open to the outside. So this is the first step, and it's this year normal. This is the planning of the Ministry of Health in Belgium. Quite ambitious. Second step, if you see, the patient problems in 2027, next year, we have to patient problem in SNOMED CT. Okay. In my hospital, we have patient problem in SNOMED CT, but not exchangeable for the moment. So it's quite a challenge. Next step, in 2028, procedure observations, allergy vaccination. It's quite a lot also. And then in 2029, we have to cope with the clinical workflow because your system is maybe functional, but if the doctor is not able to use it, you have a big problem. So this is the planning. This is the official planning. I have said, okay, we will see. It's quite ambitious. So I am not sure that we are able, especially for the little hospital, I'm not sure we are able to do that within this roadmap. In Belgium also, and thank you, Luc Nicolas, to explain that, the care set. What's the care set? Is a set of information such as vaccination, such as allergy, patient consent, and so on, exchangeable between the different actors. This is explained in information layer with business rules, with data model, and then technically it's FHIR, HL7, compatible, but we have no, and that is quite important in Belgium, we have no a terminal server central to distribute the official SNOMED CT for each hospital. This is finally, after maybe a lot of years, but it's functional now. So we can say, okay, for instance, the list of the allergens, for instance, it's SNOMED CT. It's not everybody separately. We have central the list of allergens officially exchangeable and interoperable between the actors. So that's in Belgium. It's technically functional, but not yet in production. So it's quite ambitious. In a nutshell, patient problems, observation, allergy, vaccination, and procedure too, and then exchange patient summary. So that's the message for the hospital. They just have, for the moment, okay, they begin to know that it has to be that way. It's just the beginning for us. This is not my hospital. This is the big hospital in Liège. My hospital is quite tiny, 246 beds. Quite in advance for SNOMED CT, but I will share another experience with my colleague of CHC Mont-Liège. This is a network of hospitals with two German-speaking hospitals, Eupen and Saint-Vith, and this is a big hospital with, I would say, many activities, research activities. So it's quite interesting, and I have had the opportunity to have a project data capabilities to use the text from the electronic healthcare records and to extract allergies, vaccination, and oncological diagnosis. This is a summary of the project. So we extracted all the information in text from the electronic healthcare records. We are using artificial intelligence, natural language processing to extract the entities, classification, and then we have coded those information in SNOMED CT. I will explain that later on. And then we have pushed information into FHIR and into OMOP. OMOP is quite standard for reusing information. So for the first, I would say for the primary use of data, it's FHIR. For the secondary use of data, research and so on, it's now OMOP. This is a quite summary of the results. We have processed about 9 million documents, and then we have extracted the allergy, observation, vaccination, and oncological diagnostics. And then it's quite important because it's not always easy to do that. We have crossed this information from the hospitals with the summary in general practitioner summaries. Patient summary here, called SUMER. SUMER is summary of electronic healthcare record. This is a summary from the general practitioners for the same patients. So we can cross the data, and we can cross the data also with the, I would say, the structured data, billing data, lab data, cancer registry data, and so on. So it's quite interesting to do that. You know, the workflow is quite easy: extraction, natural language processing, SNOMED CT, and then fire on OMOP. I would take this OMOP in parallel and not in sequence. So this is the same. Let's take an example to see how it works. Allergic rhinitis due to pollen. Directly, this is a text from the practitioner, from the doctor, and then we can extract the causative agent, pollen, the manifestation, allergic rhinitis, and type of allergy, because it's quite important in SNOMED CT to distinguish allergy and intolerance, and then a status is confirmed. Okay. We took the data model of fire, which is in the care set definition, and then we can directly identify causative agent, manifestation, and so on. And that's, I would say, the main result for me of the project, in place of taking those data and then directly push to fire or OMOP. No, we decided to have a common representation in SNOMED CT, which is rich and very close to the clinical information in text. In fact, if the doctor reads the SNOMED CT, he can say, okay, there is an exact match between what I meant and what the result is. And this is through template SNOMED CT technology. So we have clinical data, we have defined the clinical data in our server terminology, and we have context data. Because, for instance, allergy to penicillin, it's not the same if, I would say, the grandmother of a child said it in emergency department, or a specialist in allergology. And so the context data are very able. Just another example, I don't want to be so long, but if you are not allergic to a substance, it's not definable in fire or OMOP, but in SNOMED CT, you have this information. Just here, we have wrote an abstract, which is accepted for the next symposium of Odyssey, which leads the OMOP standard. I don't have the time to compare fire OMOP. I would say our conclusion is not compatible. There are projects which push the data from fire to OMOP. It doesn't work for allergy. I don't have the time to say that. So sorry for InterSystems, for instance, but it doesn't work. An very important incentive in Belgium, but I think in Europe too, that's the Ministry of Health have decided to change the system to finance the hospital. In place to code in ICD 10 and then DRG and then profile of pathology and money, they will scrap the ICD 10, not ICD 11, directly SNOMED CT to the IGs. And this is quite important in the frame of EHDS, because if you have a patient summary in SNOMED CT, you have automatically also the DRGs, and you are paid as on a hospital directly. About 50% of our revenues come from this system. So it's quite an important incentive, I think, to remember. Okay, conclusion. First of all, don't take the time of the clinician, sorry. it's quite, for the clinician, time is quality. So my approach is bottom up. I don't care about EHDS if it takes time of the clinician. It doesn't work. So it's quite important to say, we have some facilities now, such as voice recognition. I put that in my hospital, such as it's ready and it's coming. Just the AI system hearing the consultation, summary automatically generated, and then proposition of very important diagnosis and symptoms, and then you can validate on one click. Okay. So structured medical record is a challenge. It's not done today, so we have to cope with the text, and it's good because the granularity is in the text. And third, sorry, Luc, for that, but interoperability to connect primary and secondary use is a distant target for the main hospitals in Belgium today. So it's just the beginning of the journey.
Thank you. Thank you very much. I'd like to welcome Dr. Iztok Štotl, who is a Slovenian doctor and medical researcher. He specializes in metabolic diseases and diabetes, and he works at the University Medical Center in Ljubljana, and he's also a representative of Medical Chamber of Slovenia, and of course also expert in digital health and also in exchange of data across Europe for clinical data.
So I will today try to talk about how we doctors see us in this dilemma, primary, secondary use. What would be the best way to engage doctors in this place? I'm talking from my personal experience because because our medical chamber is very active in governance of e-health in Slovenia. I'm currently leading the governance group, so I will try to share my experience on this. So there is no doubt that connecting primary and secondary use has many opportunities and positive effects. And how do we want to have it? We want to, as was told by my previous colleague, we want to see secondary use that we come from this bureaucratic necessity toward meaningful use with single entry principles. And what we are trying to do now is to do it clinical first. So generation of statistical, administrative, and billing information should come from clinical information, and we are working on use cases to actually make it clinical only. Clinical first, clinical only. And critical factor, usability, as was already mentioned. So to be practical, I will guide you to the diabetes use case. So there is an IHE-Home set of patient-centered outcome measures published in 2020 that describe essential set of clinical outcomes related to diabetes control, acute events, chronic complication, health service utilization, and survival. Those are diabetic specific. But just for example, we could also, and we should combine with other domain diseases, other chronic diseases, other domain diseases like double threat. Diabetes is practically a factor for antibiotic treatment failure and resistance. And this should be, we should be able to get all the picture. So, but what we are currently doing, this is published research from our group, and we studied diabetes registries in Europe, and it's 2021, and you can see that the biggest heterogeneity lies in data sources. So the registries are, regarding the different countries, are very, very heterogeneous, but only few are population-based, and even here we see percentage of total population with diabetes on record during the last year. We see that there is a wide variety, but even those, the good ones, are usually based on administrative data, so there are really very few good clinical examples. So this is a current situation that's not good. But EHDS has practical potential for near complete coverage and longitudinal, and then on add-on longitudinal outcome analysis via access bias. So, but what do we need to achieve this? And this is experience from our country when we are actually working working on this. So we need shared governance forms. So we need close alignment of indicator developers with primary data collectors. So there should be a dedicated place where this should happen. And we don't usually have those places with enough capacity. So we need capacity for inclusion of stakeholders and end users. And we are working now on this, and it pays off. It's really a pace to invest in this capacity. So you have someone to talk with those who develop indicators. And this is what should be done. And as it should not be stated too many times, effective solution require optimization and point of entry, but both. So when you are planning indicators creation, you should plan it together with those who will enter it. Okay, let's go now with a practical dilemma of EHDS indicator creation. How do we now think when we are thinking about primary and secondary use and making a bridge? What do we actually mostly do? We say, okay, we have some parameters that are in data sources, that are in registry networks or nodes or national nodes, and then there's EU data. And then we always think, okay, let's select some parameters, create common data elements, and we will create indicators. And this is what we do usually with our ETLs. This is our common path. But in reality, we are in this situation. So we have EHDS. It's highly complex. And I thank you for the question before about contexts in different countries, because there are totally different contexts. And if you want to compare indicator, you cannot do this last approach, because it won't work and it won't be useful. So you need to take into consideration data sources, heterogeneity, practice, clinical practice, then biases, quality. And so we need a context around indicator. This was mentioned in prior talk. Okay, but how do we store those contexts and how do we manage those contexts? And if we ask ourselves this question, we see that we don't have good tools for this. And what do we need when basic CDEs are not often enough for full insight? So we need general metadata models for describing the indicators and the data from which they draw together with contexts. This is what we need. And my group has published such an example, such a model. We created a model that actually creates a meta model for contexts. So we created a generic framework for the semantic contextualization of indicators. Why do we need this? We need this for why is this helpful? This is helpful for creating a truly contextualized indicator vault that stores all the complexity, and it also stores it in fair manner. So all the contexts are available, findable, accessible, interoperable, and reusable. This is highly needed, and this is what we don't have, and we created this. But let's come back to our medical chamber. How do we doctors now? How should we be included in this EHDS? What would be our practical entry points? On primary use of data, there are good things happening. So we have what we need is simple visual tools like designer tools that are appropriate for doctors. And now we have some data modeling tools like clinical knowledge manager for clinical models. And we have EHDS data catalog that then we see what we now have on what use. But on the secondary use, there are rarely good entry points for clinicians. And this contextualized framework creates this fair indicator laws that's then readable and that includes the context. So this is important because it's not only the data, it's not only indicator. We need a designer tool for indicators, visual designer tool for indicator schema, and for fair indicator walls. So for conclusion, the last slide. What we need. So there is what we need. There is a big potential for improvement in quality of care in bridging primary and secondary. This is no doubt. in my opinion, technical standards are not the main barrier anymore. So we need inclusive governance structures, visual tools, and capacity for change on end user side. This is what we usually don't have in formal way. And when we want to combine both infection control and chronic disease management, then we need specific experience from disease domains that need full contextualization of analysis results. So it's not data problem. It's you need domain expertise and entry points so that we can have meaningful results for secondary analysis. Thank you. This is from my side.
Thank you very much. That was really interesting. And about domain experts, we have here Bram Lestrade, who is the microbiologist, biologist. They also member, actually the chair of the Dutch National Editorial Board for Semantic Standardization in Medical Microbiology. He's very active also in the HL7 Laboratory Semantics Group, and of course expert in microbiology. And he's also founded a specific group for digital medicine and interoperability within the European Society of Clinical Microbiology and Infectious Diseases. Please, Bram.
So this presentation was for the challenges of clinical microbiology interoperability, and of course there are many challenges, and I can only pick a few selection here, and I will focus on semantic coding problems. I will skip these two slides just because of time. I will actually go right to the, which I think is the main problem, is that ultimately, well, there are guidelines and there are courses and whatever on how to code, how to standardize your data. But ultimately, how are we going to ensure that the individual laboratories, because those are going to have to semantically code their test results, who is going to guarantee that what they do is correct? Even if they are trained, even if they follow the courses, which might not even be obligatory, how are we sure that they do not pick the wrong code, so to say? And I think this might be a bit overlooked. Then suppose, next step, say even if we have experts, say we have educated our colleagues very well, but even then, look at this, for example, if you look at a code for, say, Lyme serology, Borrelia burgdorferi, IgG, if you look at this component and you look it up in the link, you have so many codes. Which is the one you need in your laboratory? Even if you have perfect knowledge, there will be discussion because it all depends on what details you actually want to provide, to exchange. And this will pinpoint the choice you're actually going to make. Even if you're doing exactly the same test in lab A and B, they might very well end up with different codes. Then there's the issue of incompleteness. We might think that there are codes for everything. Well, that's really not the case. The LOINC and SNOMED are really incomplete. And just as an example, molecular medical microbiology, but I think also human genetics, it's developing very quickly. It's a very difficult field, and it's not really detailedly standardized yet. So this is I try to make a picture of the evolution of interoperability standardization to make it a bit playful. I think we might be somewhere here in the middle or at the left part. So right now, or maybe in the past, laboratories and countries and institutes, they standardize, well, according to their own rules, right? They choose elements, they think they choose some codes and the syntax, etc. And ultimately, we want, of course, that everyone has the same playground, the same syntax, but also uses exactly the same pieces under the same conditions. So if I do this lab test in my lab A, I would like to code it in exactly the same way as it is coded in lab B, but we're really not there yet. It will take years, I think. I think in the coming years, we will be more here. We will use shared dictionaries. So SNOMED, LOINC, and for sure there are rules and there's this implementation guideline of of the EHDS, etc. But there will be really a lot of freedom to make your own choices in the dictionaries. And ultimately, we want to go from here to there. And I think we do not only need information specialists for this, but to get to this comprehensive list, we also need input from the field, so laboratory experts, clinical microbiologists, etc. How much time do I have? Sorry. Oh, well, that's okay. Then now we're going even a step further. So we were talking mostly, actually, implicitly about primary care, about the data which is being generated for primary care. And let me take the example of antimicrobial resistance reporting and surveillance. I'm actually not so afraid that in the next few years, I think we can achieve standardization, even harmonization of antimicrobial resistance reporting in the EHDS. We with the semantic work group HL7, we are already busy with trying to make a white paper on standardization, etc. So this will be achievable. But what happens next? Because then we have all the laboratories, they are mapped to these standardized items. Okay, that's already really nice and quite an achievement. But then the processing of these data for secondary use, so making really national or European reports, etc., that can still be, everyone can do it like their own way, right? So maybe in the very near future, we should also try think together to really use one common model. So by that, you prevent that, for example, the Netherlands, my country, it has its own peculiar, well, it is a good way, but it is its own way of reporting resistance on a national level. But it should be streamlined, of course, with other countries and the ECDC, etc. These were my conclusions. Well, garbage in, garbage out, of course. If we do not build capacity, if we do not have our colleagues help our colleagues with actually coding the information in the right way, it will be, well, a disaster is a bit exaggerated, but it will be a problem. Then if we want real harmonization, not only using the same dictionaries, but also the same words in those dictionaries, I think we need more communication with our the professional clinical society, so to say, so to get these comprehensive lists. Then there are still gaps in coding and molecular microbiology is an example. I think we need a specialized task force for this, also for human genetics, I think, actually. And then standardizing the base of primary care is just a start. But then if we have those data, you also would like to put them together in a universal framework, so to say.
That was really nice. Thank you, Bram. The picture in the middle was a bit scary, but let's hope to get to the third one. In the nice slide with the 3 images, let's hope to get quickly. The one in the middle was a bit scary. So you mentioned ECDC, and our next speaker will be online, not connecting from ECDC, and it's Luís Alves de Sousa. He's a medical doctor and certified public health medical specialist, and he is also focusing on general communicable disease surveillance systems and health-related activities to support EU-level public health surveillance.
Good morning again. Thank you, Jenny, for the presentation. Thank you again for the invitation to present. I'll try and give you a very brief overview of what ECDC does and how the expected benefits of EHDS, both for primary and secondary use, could benefit EU-EA level surveillance. So the European Center for Disease Prevention and Control is a centralized public health agency of the European Union, headquartered in Stockholm. We're just over 20 years old now. And specifically, we have a legal mission and mandate to protect over 500 million people. Specifically, it's important to state, just on communicable diseases. And we're aiming at assessing public health threats to EU-EA and provide guidance to prevent and control these threats. It's very important to also state that ECDC works under the strict cooperation of EU member states and EEA countries, specifically on the field of public health surveillance. And this includes surveillance data collection, validation, analysis, and dissemination of this information to the public or specific public health stakeholders, always working with specific national competent bodies. And so there's a lot of discretionary power that lies, of course, under the EU legal frameworks with member states and the power that they have to implement or further implement on existing EU level law. In aspects of public health, this is important. It will happen likely in the EHDS. ECDC provides a specific technical platform for public health surveillance data collection, inbuilt validation, storage, and retrieval. And so this basically means that member states with their public health agencies or institutes report to ECDC a set of mandatory information, what you could call statutory surveillance data. And this is reported to this platform called EpiPulse, which I will sort of mention in the next few slides. This, you could call this a legal interoperability layer that was established with the foundation of ECDC and then with the serious cross-border threat to health regulation. It defines a legally binding list of more than 60 communicable diseases and special health issues like AMR that are under EU level surveillance, and so that member states need to report to ECDC using specific legally defined case definitions. And so this means that there's an aspect here to transform this sort of legal interoperability components or legal components and its legal interoperability definition with this framework, then to aspects of further digital health. And I will refer some of those in the coming slides. There are then other aspects that we have harmonized in EUEA surveillance, the part of standardization, laboratory diagnostics, and EQAs and training on that aspect. The centralized surveillance data validation that happens with the EpiPulse, and then specific metadata components that we have established for how you report this data. And this happens what you could call, or what we call EpiPulse reporting protocols. They provide guidance to countries on how to report data, and you see an example on the right for integrated virus surveillance with 3 variables and the type of sort of code values that we have used. It's important to state that this nevertheless represents a closed system, and so it's a very locked-in system that we've used between ECDC and our national counterparts. So it's not very, let's say, it's not the most interoperable system in the sense of public-facing systems, but it works for our use cases and for our stakeholders. We tend to update it quite frequently depending on reporting needs, and you have disease subject-specific metadata with specific variables and specific value sets for them. There are aspects that are important and should help guide the development for EHDS, and I'm placing the ones that we took from the COVID-19 pandemic because they, in the end, should help decide aspects on how to implement things and the rationale of why you would implement them. In COVID-19, we had an extraordinarily high demand for timely and high quality and representative data. We had strained healthcare resources and specifically public health resources. We had established very non-scalable processes for several steps of surveillance data collection and reporting. We had representative limitations on the way we collected data, and we had very heterogeneous systems across, even sometimes within countries, specifically on the collection and use of health data standards. And so all these aspects represented hurdles in addressing the pandemic and responding to the pandemic. And so there's a rationale here that could be improved with EHDS. So there are direct benefits that we expect from the health data standardization and interoperability that could be provided by the EHDS, more resilient and adaptable surveillance systems as a result, both in reducing the burden of reporting at different levels, so both from the clinician but also at the public health agency level, a progress in the automation of surveillance data reporting, in the ability to link data sources to get more timely surveillance data reporting, specifically on the early detection of new or unexpected events to support further epidemiological studies and to improve the surveillance data comparability. If you look at specific aspects of the application of EHDS primary use, and in this case, I think I would like to make perhaps the sort of pointy comment that even though sometimes public health is seen strictly as secondary use, you saw just now with the example of the meningitis outbreak in the UK with Kent, how knowledge of public health, of clinical aspects is very important to guide, for instance, chemoprophylaxis or to guide community-based vaccination initiatives to control an epidemic and an outbreak. And so just to very focusedly and narrowly see public health strictly secondary use limits and curtails our ability to actually address public health emergencies or public health outbreaks. And in that regard, the EHDS primary use for national level, not for ECDC level, but for national level, poses two advantages, both on supporting public health response, but also then on aspects that will harmonize the systems that they can use now and they can use in the future. So there's an inbuilt harmonization, possibly at least, in the EHR digital system that they will use. There's a common reference in different layers at legal level with EHDS and technical and semantic with Article 15 and secondary legislation that would come from it. But also there's a natural current investment, infrastructure at least, and member states to actually put in place the aspects, the infrastructural aspects of EHDS primary use. A benefit that could come specifically for statutory public health surveillance, some things that already sort of exist but could benefit from the fact that we now have this common reference in different layers. One of those is, for instance, the aspect of electronic case reporting and electronic laboratory reporting, the EHR-based triggering, and this was something that was implemented by the CDC called the reportable condition trigger codes. So if someone codes a specific code that is under this legally binding list, then the form to do the reporting would appear in the EHR UI. The digital phenotyping, specifically the translation of this analog list of case definitions in PDFs to digital case definitions that know or can use this common reference to help identification and reporting of cases. At a later stage, you could consider the possibility of using clinical decision support systems, albeit these systems will likely take a lot more time because they are obliged to what's called dual regulatory compliance. They have to abide both by the medical devices regulation and the AI Act because they are under the risk AI software. And lately, of course, because there's an harmonization of this aspect, subsequent collection of evidence for studies and to guide public health recommendations addressing evidence gaps is another benefit. Thank you very much for your attention and open to questions. Over.
Thank you so much, Luís. I think it's really interesting, right, to hear this really the different viewpoints. Now we moved, of course, to the public health part, and we're going to continue with the public health with Sophie van Wingerden from the Dutch National Institute for Public Health and Environment, and she will talk a little bit about the Dutch experience, so also connect a little bit maybe with what Bram said earlier, and I think she will say something about the standardization efforts in infection surveillance in Holland.
Thank you, Eugenia, for the invitation and also for the opportunity that I could share my project on a federated automated surveillance. Yeah. 10%. Yeah. And I would like to share our lessons learned from the exploration of EHR data harmonization and standardization. And I worked together on this project with Stephanie Verrode, but she couldn't be here, but she's online if you have any questions later on, maybe. So first start with some background on automated surveillance, where algorithms are applied on routine care data to replace the manual steps. So the manual steps are in selection of patients, and the collection of information, patient characteristics and risk factors, and also classification of a patient's infections, yes or no. So this reduces manual decisions and also reduces workload and also improves data quality. But there also are various barriers that limit the large-scale implementation of automated surveillance. So if you look at, there's limited capacity and knowledge within the hospitals to implement this. And also there's a need for more advanced analytics if you look at AI and more complex algorithms. So that's complicated to implement it centrally or locally in the hospitals. And also there's a need of sharing scripts and applications, and also to arrange the agile access to the data. So one of the solutions is federated automated surveillance, where the algorithms are developed centrally. Here is the RVM, the Dutch National Health Institute, but could be the other coordinating center. They are pushed to the hospitals and then locally run. And then only the aggregated surveillance results are pushed back to the coordinating center. So one main advantage is that the source data stays local, so it aligns with GDPR. And also, if you look at this, and there's one algorithm developed centrally, then you need harmonized, standardized data to run this algorithm. So that's a requisite. And then that's what we found out, that we try to determine the potential and requirements for a federated automated surveillance. And one of the sub-goals was to make a definition of a common data model and also do the data quality control and for a specific use case, and that is the automated infection surveillance of surgical site infections. And I'm from Rotterdam, and I really like this painting. It's in the Rotterdam Museum, Boijmans. And I think it's really nice that we stand maybe at the second, third level, but we want to aim to one language. I think Bram mentioned also a little bit. So we started out with a Delphi study to define and mapping of to the standard terminologies. So if you look at the figure, then we started at the left side for the specific use case. It's ortho, you can forget it, but it's the use case of surgical site infections. There we have the data specifications needed for the surveillance. Then we try to map it to standard terminologies, but also look at how is the data registered within the EHR systems. And then the main questions were, do all stakeholders holders agree on the mappings? And the second one, and I think that was the most difficult one, and you mentioned it already, is do all stakeholders have the same understanding of the data elements and the context of which the data was registered? The use case is surgical site infection surveillance after orthopedic surgery. Just to keep in mind what kind of data we have. We have general patient characteristics, but also surgical procedure and medical microbiology. And Bram mentioned it a little bit. It was not so easy to use that. And we started to align with other national and international initiatives for preparatory work, but also how do we compose this working group that we need for the Delphi study. And then we came up with 12 domain experts in different domains, like the medical informatics, we needed those, the infection preventist and medical microbiology, and orthopedic surgeons and IT specialists. So we come up with an 85.1% consensus on all the items we had on the mapping, the semantic mapping. And what Bram also mentioned, the microbiology data was more difficult to map to certain standards. It was also, if you look at it varies in the protocols within the hospital. So some of our data elements were, is the swab result positive or negative? So that's already actually an interpretation, because the positive or negative result can differ between different laboratories. So we have to make a more minimal data set to start off with. So the main lessons learned were that the data is registered for care. So that's why the doctors register it, or the lab registered it. And there's different culture practices. And also you have to always keep in mind what's the fit for purpose and what kind of this data do we really need for our surveillance? Is it the right data? Also, how do you find the right data? It's difficult because in the beginning, of course, you need the domain experts. They know what kind of data you need. But then when we ask, we really want to see, well, how is the data registered? What is the source data? Is it the data in the data warehouse, or is it like really the source data? And also, what is the context? I think everybody mentioned it there already. So do we all mean the same? Do we all select the same data to standardize it to certain terminologies? And here you see like the first round in our Delphi that we had some data specifications, and then we proposed some mappings, and then the working group can decide which of the mappings they agreed on most. Yeah. Okay, then we had the semantic mapping, and then we wanted to try to test it in Connectathon. It was for us a one-day event at RVM with 3 participating hospitals. And we had 3 pillars of testing it that day. The first one is the compliance. So if you look at the figure, we started with the source data, we mapped them to standards, and then we mapped it to an OMOP common data model. We used it in a web-based application tool, and then we had the results. So the 3 pillars were the compliance of the ETL process. Can we map the source data to OMOP first? Second, does the source data actually load into the tool, and can we just is interchangeable? And the last part is the algorithm results, the most important. Are the results comparable if you do not transform the data to the OMOP CDM? Now, our results were that we had a successful demonstration of the ETL principle, like the data could be extracted. That was really nice, and also it could be transformed to the OMOP CDM and also uploaded in the application. We had real great insights in the whole data pipelines, dependency and requirements, especially what kind of capacity we need and what kind of expertise. And one of the most important things was that you need the uniformity of language, so the mutual understanding of what kind of data are we talking about. Is the context the same? That all roles need to be involved, and especially in the beginning. So start collaborative. We started out in the beginning like we were trying to find out how to map the data, and then we asked the hospitals, but then they couldn't find the data in their systems, because I think if you start earlier on, that you really understand each other's processes, that's a better start. If you look at the compliance, we did map the source data to OMOP. We have a mapping table. We developed a generic ETL script, and also did some basic data quality control. Also, if you look at the interoperability, all data was loaded into the web-based application. Sometimes the data shifted a little bit, so we need more in the understanding of the relational model of CDM, of the OMOP CDM, but we're almost there, so that's nice. And the validation, we're still working on that because we had some shifts in the OMOP CDM. So main lessons learned, domain expertise in hospitals is pivotal, but the collaborative start is essential. And learn from existing initiatives, and also optimize a more generic OMOP CDM and more specific logic in the application. I will, for example, we asked the hospitals, we need reoperation, but they couldn't extract it from their, that's logic, but they couldn't extract it from their EHR systems because it's already an interpretation of the data. What is a reoperation? So a bit more generic CDM, you just need operation date, and like the provider or someone who performed the operation, and then later in the application you can decide, oh, is this a reoperation, yes or no? And the future steps is that we are organizing a Connectathon 2.0 to enhancing the OMOP maturity level. We have much more data quality control steps to do, and also use more tools OMOP provides. And the second is to make it totally fair and maybe explore the RDF. And then the question Eugenia said me, like, what's the main question for this topic is, how can the flow of data better be supported, and challenges and opportunities for the public health thanks to the EHDS? So first, interoperability will be promoted with the EHDS, but not how exactly. So the data will still have to make interoperable, and expert domain knowledge and collaboration is pivotal. And also in the interpretation and selection of data sources is crucial. The importance of, is this the right data for our purpose, and also the context of data, of course. I think we all agree on that, and the quality of data, of course. And then we need bridge builders to connect the technical experts with the domain experts to really find the right data for the right purpose, and a need for overall coordination and alignment of all our projects and other projects. Thank you.
Thank you, Sophie. Okay, so thank you also for introducing the more technical part, because this last part, the last three speakers are actually more into the standards part. So we have Giorgio Cangioli, who is the technical lead in IHE-Europe. He's also a member of IHE International and also vice chair of IHE Italy, and he's the point of reference basically for all the FHIR implementation guides for the EHDS, and he's obviously an expert of IHE FHIR.
Good morning. I'll try to be brief. I think that most of us has a dream, that of not putting the hand and put the data in the registry, recopying or searching things around. So this is what I believe each of us try to do. We know that we need some work to be done. It's not automatic. There is some extraction, some thing that needs to be resolved. But this is the thing that we would like to have. We have a good new thing that the regulation include inside the single regulation the two part. However, maybe I have a wrong opinion on that, but I still see that that regulation doesn't solve, because the two are treated as two separate channel, even if they should not be. My impression is that there are two separate things and thought in that way. So has standard development organization, what we can do, what we can try to help, try to not solve, but to help in that direction. one thing that we can try to do is to, as possible, to support by design the fact that support for primary and secondary use. We all know that each of us would like to have their problem solved. So if I need to treat with a tumor board, think I need to have my problem resolved. I don't care if that data is used for secondary use. Those that need to make research would like to have their data and without taking into account what is the actual need of who is treating the patient actually. Sorry, I'm exaggerating, but more or less, this is the type of discussion we have in our group. The other thing is that we need to be open for multi-standard. Think that there is one solution that fits for all doesn't work. We need to, as been mentioned already, we have some standard that are used for exchanging, maybe for primary use, other that are more used in secondary use. And we need to help in order that all of them need to work consistently together. And the thing is that it's not just a technological matter. Our cultural aspect is not just to say, from the technical perspective, is it best or not best. We need to understand that some group of people are used to work with some technology. There are different expectations, different needs, and all are things that we need to consider. So let me try to just present one, let's say, attempt that we have done in that direction. That is the work on the European Common Cancer Model. We have started an initiative called Phoenix. The idea is to engage directly the stakeholder in development, not to say join us, but please be the driver of the activity. You are the main user, be those that drive with the help of the standardization body, but you need to drive consistently and try to speed up the implementation and foster the adoption. So who are the founding members of this initiative? We have some National Cancer Institute, we have some hospital, we have some research institute. These are the core founding member, but we hope to have more and more organization engage. As you can see from the vision of Phoenix, the plan is to work for interoperability that look to the care provisioning, but also to the research by trying to promote a unified approach and try to close as possible the loop between research and the care provisioning. Obviously, all that aligned with the health data space and try to also foster the creation of a unified ecosystem. The first activity that has been promoted by Phoenix is the European Common Cancer Model. The idea is to define a minimal extensible, non-exhaustive data set, not specific for a type of cancer, that is designed to be used for both primary and secondary usage. I should say that most of the contributors of that model are researchers. So there is a little bit of bias on that. This is one criticism that we receive, but we are still in time to work on and to improve it. And the idea is to have that represented into FHIR. The plan, we work with the help of a lot of clinicians to design the conceptual model, not only from the statistical point of view, but also to try to understand how the information flow and change during the journey and if you can show you if you are interested in the result of that work. Then we work on having more detail and more, let's say, technical vision of that conceptual model represented, with the idea of having them represented both in FHIR and in OMOP. So this is the idea, not to say you have FHIR, extract from FHIR and OMOP, but the core is these are the information. Let's try to assure that these information are conveyed consistently in the two-way. And this will be presented in the next LDSI Europe meeting in Rotterdam, and with the hope to have some additional input from that group. Sorry. So we know that is not a silver bullet. We know that we are not solving all the possible problems. But we think that with such a kind of initiative and approach, we can have a good starting point to try to resolve at least part of the thing that we are dealing with and try to achieve the dream that I mentioned at the very beginning. Thank you.
Thank you, Giorgio. Very interesting. Then I wonder if terminology, so we have different models. We see different standards for maybe FHIR and OMOP, maybe one for the data exchange, one for the research, but maybe terminology could be something that links these models. So with this, I would like to introduce next speaker, who is Licínio Kustra Mano. He's the customer relations lead for European at SNOMED International. He works with governments and national authorities to enable the adoption of SNOMED in the European countries. And he has a long experience with European initiatives and especially with the EHDS in his past. And now I'd like to leave the floor to you. Thank you.
Thank you very much, Adi. Good morning, everyone. Thank you very much. So let's look. Some of you have been participating in the sessions before, so you already heard some of the messages here. Today, we'll focus mainly on secondary use of health data. So according to the World Economic Forum, 97% of the data generated in the hospitals remains unused. So it seems that the healthcare sector is rich in data. 30% of the world data generated is from healthcare, but poor in insights. And this is a challenge that is not new. It has been already shown and highlighted by many of you. But at SNOMED, we try to monitor the barriers for that. And two of the barriers, there are more, two of the barriers are the legal uncertainty. People say, in order to get data at scale, it's not enough one hospital. I need to have 10 hospitals across Europe. So how do I have a legal process that allows me to do that? And then it's what everyone has been mentioning is the poor quality, data quality, and how to address it. So by looking at that, well, this picture is becoming like one of my favorites. My past has been linked to the European health data space, so I try to humanize it and say the EHDS saves the day. And well, it's a joke, but it's a belief from my side. So one of the things that I believe the European health data space introduces is the legal and ethical path harmonized across countries in order to access health data at scale. And all those articles that are there in the secondary use describe that and try to make it to make sure that data is available for research, innovation, and policy making. So this is the basic thing that I believe that no one of us can change, but the European regulators can, and I feel very happy about that. The second thing, entering in the poor quality of data. At SNOMED International, we believe that the right place to start increasing the quality of data is at the point of care, increasing the precision of capturing data at the point of care. But it cannot come with the effort of increasing the burden of health professionals. This was already mentioned here. So we believe that now the time has come where technology caught up. So it was mentioned already how to use SNOMED using terminology services. It's not just about a technical approach. It's about how when the doctor starts typing something, 3 characters, it gets the right match to that to those words, the clinical concept it has in his mind. And that is not about just the fast relation between the terminology server and the graphical user interface. Is also how that value set that is being searched match what is the field that we are talking about. Is it diagnosis? It's something more. So that usability thing is important to not increase the burden and not to speak about AI with all the describing solutions that we have been working with the developers of this technology while the doctor is saying things, the describing technology captures the text, but then the challenge is mapping this entity linking, it was already mentioned here, to SNOMED CT concepts. So this is where we are working with the vendors to make sure that these scribing algorithms are really good. So we believe it starts here at the point of care. So we try to work with the vendors to increase that. But of course, the European health data space is coming forward with something that is extremely helpful, is this European electronic health record exchange format. So common structured way to represent data for patient summary, prescription, laboratory results, discharge. So we'll hear all about that, but it will come also with one step forward saying, oh, but we should use common standards. Let's see how far it will come in terms of defining the standards for each data element in the data fields. It's about to come. So SNOMED will play a role there. And for the ones, I will not spend much time because I heard SNOMED CT expressed in several presentations. I will only highlight one thing that it was not mentioned yet. So when we speak about secondary use of data, we need to do it at scale. One of the challenges is if it comes from Portugal, is in Portuguese, and if it comes from Finland, is in Finnish. What SNOMED CT provides everyone is it's used all across the world. So the same concept, even if it is encoded in Portugal with the Portuguese language or in Finnish with the pneumonia in Finnish, it will have the same underlying code ID, concept ID. So language doesn't interfere in your analysis. It helps to scale. So I would only emphasize that additional characteristic for that. Now, it also mentioned that no terminology solves all the purposes. So that's why at SNOMED, we try to work with all of these partners around, as you see here on the table, to create the ecosystem, meaning you are not locked in. When you start, you can start from something, ICD, LOINC, and you come up with SNOMED or the other way around. So we try to work with these organizations to make sure the ecosystem is really truly is bidirectional. I wanted also to emphasize that what we call the terminology integrator, collect once and reuse many times. This is future proofing, making sure that this is part of the strategic vision. Now, in the secondary use, when I mentioned there is a harmonized process on how to get data at scale, it's always important to add this. It's not about a single hospital, it's bringing together several hospitals. And this is the depiction of that process, legal process and trust ethical process. And there is one moment where data is brought into a secure processing environment, and then you need to analyze the data. And that's where we believe that there is a common issue. That is, but what are the standards for the data, bringing together different data sources from different hospitals? How will we put it together in a way that we can analyze data and compare data? And you have already been mentioning this, highlighting. Many of you spoke about the OMOP, Common Data Model. What we have been doing is working with OMOP to try to see how can SNOMED CT be used on that. And OMOP is using SNOMED CT for conditions and for procedures. So it's also part there. So they create, whenever someone uses other code system to encode diagnoses or procedures, then in the ETL process that was mentioned, extract, transform, and load, it's transformed to SNOMED CT. If you have already collected it at source with SNOMED CT, that process is not so, let's say, difficult. So this is one example on what you can achieve in terms of gains. Sometimes it's not about just saving money, it's increasing the efficiency of the time and the efforts that you put in a policy that in this case was the Norwegian public dental service that found the potential gain of 6 million by reducing the time with the low risk patients. It's not just not seeing the patients, it's reducing the time from 30 minutes to 15 minutes and how that translates into gains that can be changed to other patients. Now, so the last message I wanted to pass is the following. SNOMED CT is very difficult to use in terms of it's a technological framework. But what is important message here is how do you start to build, if you are a data organization, a healthcare organization, if you consider yourself a data organization, that data is not a byproduct, that data is a layer that enables your business. The question for you is how do you start your foundation on a layer that has, it's not locking you in, it is a clinical language by definition, so it brings clinical at first, and then it provides you the computable model that enables the tools to extract value from that data. So that's the message. Find that, look for it. We believe SNOMED CT, or we are designing SNOMED CT to be that foundation, but it's up to you. Our challenge is, or we challenge you to find that answer for your organization. If you'd like to learn more about SNOMED CT, there are some links available in the presentation. I'm sure if there is some burning questions, we can meet outside and answer those. Thank you for the invite.
Continue. And yeah, I mean, I think it's a great. I mean, I see that we need to rush through the presentation, but I think it's such high quality of all the presentations that I'm really enjoying this. So I'd like to continue now with standards, and I think we'll dig a little bit more deep into OMOP with Ankur Krishnan, who is a data and project manager at Heidelberg Institute of Global Health, and he's involved in several EU projects working on open science and fair principles, and he focuses on interoperability and also harmonization and standardization of data for infectious diseases, and I think he will now present us his experience also with, in particular with OMOP.
Really good to be here actually, and I sort of must, I think, apologize in advance because I realize I'll be most likely preaching to the choir here because I'm going to echo a lot of the things that have been mentioned already. So just to give you a quick context of how I and sort of my team started working on OMOP CDM is that I come from this project called EHDS. And EHDS stands for European Clinical Research Alliance on Infectious Diseases. And a core part of the project essentially are these 5 observational studies on different, which we call perpetual observational studies, on different disease areas in different healthcare settings. And so it was very important for us because this, in a way, sort of provided us with this microcosm, which sort of reflects this larger, obviously much more complicated research landscape of different disease areas in infectious diseases and healthcare settings. And so the data collection, it is still a very controlled environment in the sense that it's a singular project and data collection is through these case report forms. And we have a lot more control over the data quality and the provenance. But this really did provide us with a really interesting opportunity to explore different ways of fair compliance. So first, the why part of it, right? So we didn't directly jump into OMOP CDM or directly choose OMOP CDM. For us, overall, as a project, it was very important to connect to this open science principles and adhere to them as much as possible, but also then be as fair compliant or as fair by design as possible. So to be as proactive and prospective about it. We also wanted to establish a certain level of harmonization within the project. And I'm going to briefly mention the difference and why I will use harmonization separately from standardization here in certain instances. And then for what purpose? And here the purpose is not necessarily clinical research questions of the clinical purpose, but for us, it was important as a project which has these observational studies and a network to be able to embed clinical trials and intervention studies as well as be observational studies. And so to be compliant to regulatory submission requirements, that is, therefore we chose CRISC, and then to essentially enable data reuse through Federation through OMOP CDM. So the decision-making process first was to think of Federation and then to finalize on, or at least try to sort of narrow down on different ways in which we could actually enable Federation. And so for OMOP for us was very important in the sense that we realized it's something which is privacy by design. There is a very strong existing community and infrastructure and a support system around and tooling and analytical packages, which really helped our team within the project. So just a quick point that I want to mention here, essentially, because something I had noticed in a few other slides also is it was very important for us, again, this is before we actually decided on OMOP, but to decide on certain level of common data elements for which were sort of, let's say, a through line between all of the different disease areas and different studies and healthcare settings. And I think one thing I want to point out here, essentially, which is very important in this larger context, is that it's not just about the microbiological data, but the context, the clinical context of the events and the procedures and the outcomes that also need to be harmonized as much as possible as you do any work in standardization though. So just again, a quick sort of flow chart. This is still an oversimplification of how complicated it can be to actually decide how to be fair by design. But this is just to show that right from the beginning, we had to be very proactive and prospectively think about the different factors that go into deciding how to be fair by design, essentially. So I'm not going to go through all of them here, but they do actually, because it is very important, and this has been mentioned earlier also, that this is this has to be purpose driven. This is not just standardization for the sake of standardization, right? And so it has to have the representation of the different stakeholders, the expertise, not just from a standards point of view, but the clinicians, the laboratory, and all the other people. And then and again, I'm not going to go through all of them essentially, but also to have as a study, as a project which is funded, has limited amount of resources, to be aware of how much standardization is prospectively possible for you at this stage, because no matter how much you try, there will be a requirement for some level of retrospective harmonization and standardization, which is almost inevitable though. So for us, for our project, this is what it actually ended up looking like. So again, as I mentioned, the CDISC and Odyssey part is, I think, is well understood. But I do want to point out that this is not just about the data and the metadata, but it is also very important, and especially the last part that you see, the ethics and governance part of it. So as, again, proactively and as prospectively, you do, and you must think about essentially the consent, the broad consent for future use, the different sort of governance practices that you have in place that allow this data reuse beyond your project. So again, this sort of brought us to the implementation fact. And this is again just something that I want to point out because we did not have the internal capacity to do this ourselves from expertise point of view or from infrastructure point of view. This is something that we were very lucky to have this Eden project where we were able to secure some funding. So external funding, and through this project, we were also able to identify this network of Eden's certified SMEs, essentially, who have expertise in OMOP and Odyssey. So before we actually even came down to ETLing any of our data to OMOP CDM, the other very important aspect was to establish some sort of a technical infrastructure at an institutional level, right, which can sustain beyond the project expiration date, and something which can be used by other projects and can be established again at an institutional level and is sustainable, is secure, and is scalable, so that more and more different studies can actually be onloaded onto this infrastructure. This then led to the actual, let's say, OMOPing part of the data. And so this is, okay, I think this is big enough. And essentially, so something right from the beginning that we were very aware of, and we knew this would be a complication or a challenge, actually, very interesting challenge, was this innate hierarchy, which you see in microbiology data. So in the sense that patients might have multiple samples or specimens, each specimen might have different microorganisms identified, and for depending if it's a bacteria or a fungi, there might be resistance profiles depending on the antimicrobial susceptibility testing. So you need to be able to maintain that hierarchy and not just, again, just standardize it for the sake of standard. There are many different ways that you can put this into the common data model, but it has to be queryable for your end use, essentially. And so this was very important for us to maintain or try to find a way to do this in OMOP CDM. And the other thing that you see on the right essentially is, again, the clinical context of different episodes, from imaging to chest x-rays to other sort of clinical signs of pneumonia for one of our studies, which needs to also be captured in the data model in a way that is queryable along with this hierarchy of the microbiology data. This is again the same slide essentially. So some more specific, let's say, challenges again that we faced when it came to doing the vocabulary and concept mapping was for different diseases, or for the two of our studies, essentially, we realized that the way, even though, again, we are in this controlled environment of studies within a single project, there are different ways in which the studies prefer capturing, let's say, comorbidities or medical history or primary reason for admission. And to be able to maintain that level of granularity while still maintaining or while still being standardized or not trying to sort of move too far away from standardized concepts in Athena, in Odyssey, essentially, was quite complicated. And we realized one of the examples that you see between the two studies is that for two of our studies, they capture resistance profiles differently. And so for us to be able to maintain that level of granularity, where on the left you see CUTI, which is complicated urinary tract infections, and they had this conventional sort of antibiogram type structure where you have the different antibiotics and the resistance profiles. And then something like POSVAB, which is ventilator-associated pneumonia, they had out and out resistance profiles. So here you see vancomycin resistance, Staph aureus, and SI and R essentially are equivalent to a yes or no, essentially, right? And so to be able to capture that information in our common data model was quite sort of challenging. And essentially the point that I make about maintaining that granularity while at the same time being as standardized as possible. One of the things that we did, and one of the reasons I showed the common data sort of domains earlier, was we also tried to create these mapping master lists, essentially, of lists of microorganisms, lists of antibiotics. And it was very important for us to find a way to map them to the Odyssey vocabulary. So SNOMED, essentially, in this case, where our initial, or let's say, list of antibiotics were in ATC, and then we had to find a way to sort of map them to RxNorm, essentially, because that is what Odyssey requires. So to be able to not have to do that manually, essentially, was very important. Again, these are again just some points. I might not sort of, if we are okay on time, I might just not go quickly. I'll go through them quickly, essentially. One very interesting challenge that we faced was at the time of mapping, there were certain concepts which had not yet been pulled into Athena. So these are concepts, Odyssey has this tool called Athena, and it pulls from SNOMED CT essentially. So at the time of mapping, these are like calcineurin inhibitor therapy was not pulled into Athena. So at that point, it was not something that we could map. And over the time, like since then, essentially, we've been able to do this. How do we reconcile for changing sort of versions and updates to the vocabulary? Essentially was an interesting thing to think about for us. And then there are other non-standard concepts which were very study specific for us, but we could not really find a way to actually map them to Odyssey through Athena and the standardized vocabulary in that. And the other thing, I think this has been brought up earlier also, is mapping the nose and the not assessed essentially, which was very important for us because this is part of our understanding the clinical patient management and all of these other processes. And Odyssey as of now and the OMOP CDM as of now doesn't really have a, let's say, conventional or a standardized way of doing this. And yeah, the last thing, again, this is very important because I'm really glad this concept of like context came up earlier. And this was very important for us to understand how do we fit metadata. So this is not just the metadata which is descriptive in the sense there would be clinical guidelines which are used for the breakpoints, but also then which are site level or lab level essentially, or which are more discovery access or provenance level, which maintain about talk about data quality and where the data comes from. So these were some interesting challenges, and these are conversations that we've been having with the Odyssey community for a while now. And there is now a microbiology task force that Odyssey has. We met 4 or 5 times now. And interesting challenge, like a very interesting realization then was that in the past 4 meetings, we've had 6 or 7 different teams present on how they have mapped their data to OMOP CDM, different each time. And so there's a very important need in this domain-specific microbiology, infectious disease, which is a very broad category, by the way, anyways. To have this level of harmonization. So I'm going to use a few cliches to make this point because this sort of keeps coming up again and again. But so again, we always hear this, we do not need to reinvent the wheel, which is true. And so that means there are communities out there. There's the Odyssey community out there. There's the HL7, and there are the other sort of standard-specific communities out there, which are doing a lot of work, but they also need to be connected to each other so that we can leverage these communities, but also other open science communities and platforms and tools to, again, this has to be domain specific. There has to be a certain level of, let's say, guardrails for this. Then the harmonization or harmonization approaches, right? So as I said, you could do this, 6 different teams could do this 6 different ways. So we need to find a way to have a certain level of convention, guidelines, some sort of tooling, some overall governance, like a working group or something which aligns not just within each of these communities, within Odyssey, within HL7, but also coordinates and communicates with each other as we sort of move forward. And I don't know whether the last one is a cliche or not, but I think of this a lot in this sense. But it's just that we tend to do this thing where in our project, we saw this essentially. We went from a single study to 5 studies, which is a, let's say, a bigger bubble, then to connect it to the Odyssey world, which is an even bigger bubble, but still a bubble because we are still not as well connected between the HL7 and the SNOMED and the other sort of communities. So we do need that crosswalk and that coordination and alignment between all of these other sort of silos or bubbles. And this is my last slide. Yeah, I think this is more to do with addressing the question I think Eugenia sort of had, and which was, I was just thinking about what are the different potential benefits, let's say, of these communications, these crosswalks, and whether there's a need to do this or not. And I think more often than not, early on, I used to see a lot of questions about FHIR versus OMOP versus, but it's not really versus. I really don't think it's like one versus the other, as much as it's not exchange versus analysis versus regulatory submission. So you need to find a way in which it sort of connects, because these are existing infrastructures and communities. So you need to find a way to sort of connect them as best as possible, as proactively as possible, and sort of move forward from the, again, driven very much by use cases. Otherwise, standardization for the sake of standardization, where there's not a good representation of the stakeholders and the end use, is sort of going to fall flat because it's not really going to get tested the way it should get tested. I think the last point is fine to leave it essentially, but this is just something I realized in our project, is that it actually might also help having a very sort of efficient and judicious data collection, in the sense that in our CRFs, and this is a point that came up earlier also, the burden of data collection for these CRFs, for these case report forms at the hospital level is immense. And so we do want to reduce the burden of data collection as much as possible. And we do see a lot of duplication of data collected, which is already there in the EHR system, being put into a CRF again, all. And so we do, I feel, we can find a really sort of judicious or efficient way of collecting data if we can connect FHIR and EHR system essentially to the CRFs and the data collection. I think that's the last of it. Yep. Thank you so much.
Thank you, Ankur. It was really nice to hear also about this experience and these interesting also conclusions that you had about this. And so I think there is a clear need for, I think it appeared clear from what we heard today that basically we need to have collaboration, different stakeholders, a little bit like today. So we had different points of view, and I think that's very important also when building these standards, when creating these implementation guides, to call all the stakeholders on board, to get all the requirements on board, and also having these maybe the guidelines that help us go walk us through all these different standards that should help us across the different use cases. It appeared clear also that different use cases really need the really need to be the guidelines help us to walk across and through all these different use cases, and that are supported by all the different standards. So I see that we are only 5 minutes. Luc, don't look at me. We are only 5 minutes over time. So I think that was pretty good. I mean, and I'd like to thank all the speakers. And I think we also established a nice contacts with, because it was really, really extremely interesting for me. And I would like to thank all the speakers that have intervened today for their great intervention, their sharing their expertise. It was really, really interesting. Thank you so much. And I'd leave the floor to Luc.
Thank you. Thank you, Genia. Indeed, I think that in the work that we do together with Genia, we will again be in contact with some of you because we would like to document and to promote some of the key messages further. So we will reuse this material, not only for internal deliverables in the project, but for external deliverable and documenting further, because I think we really need to push some of those messages, which have been extremely consistent over the presentations, I think. Now, we have a break right now, so we go before we start the second session at 11:15. So have a nice coffee just right now, and then we come with a prospective use case, so where really we need urgently to have to collect and consolidate information, and we will have very interesting experience coming from different countries. We have from Finland, from Belgium, from the Netherlands, just to name 3, and with the participation of the patient on the long COVID aspect, where we will see very interesting things. So see you in a few minutes. For those online, just stay around. We'll be back. Thank you very much.